Welcome back. This is Chapter 7, Lesson 4, on how to solve and write multiplication equations. The usual reminders here: you need your math book out and open to page 551 through 554, and you need a pencil so that you can copy everything down. And you need to work all the examples out as well. All right, the two things we're going to learn is how to solve by dividing, and we're going to learn about the division property of equality. Make sure you copy this down. So looking at our next page, it says here a multiplication equation is an equation like 2x equals 10 because the variable x is multiplied by 2. Multiplication and division are inverse operations, so to solve a multiplication equation, you have to divide. So go ahead and write the note that I have here in red over in the work zone. And one thing I want to remind you is when we're going to be doing these equations today, you're going to see things such as 2x, get a smaller font there. Okay, this is the one that gave in the example. Over here, because the 2 and the x are together on that side of the equation, and there's no symbol between them, no math operations between them, it means that those numbers are being multiplied. So really, this means the same thing as 2 times x, and another way to write it is 2 and then parentheses x. It's possible that you're going to see it all three ways. However, the majority of the way that you're going to see it is the first way that was shown to you, where they're not going to put a symbol between the coefficient and the variable. So let's go ahead and solve this problem out. So over here, still in the work zone, go ahead and write out 2x equals 10. Just like before, what we're going to do is we're going to put a line to separate our two sides of our equation. So on the left side, we see the 2x, and on the right side, we see the 10. So what's happening to the x is it's being multiplied by 2. So the inverse operation of multiplication is to divide. And remember, what you do to one side, you must do to the other. So what I'm going to do here is I'm going to divide 2 from both sides. Now the way you show division in multiplication is by making things look like a fraction. So I'm going to put a fraction bar underneath my 2x and put a 2 underneath it, and another fraction bar underneath my 10 and put a 2 underneath it. This is how you show division. You do not want to use the division symbol at all. If I see this symbol, I'm going to go ahead and put a big slash through it. So you do not want to use that symbol at all. So going back to our equation now, what happens is these 2's get canceled out. You drop down our x and our equal sign, and look what we have to the right. We have 10 divided by 2. 10 divided by 2 is 5. So it's pretty easy. The only things you need to remember is how to show the division in an algebra problem. Let's look at example 2. Here it asks us to solve 3x equals 6, and it wants us to check our solution. All right, so we're going to go ahead and fill in the boxes below. The equation that we have is 3x equals 6. So I'm going to go ahead and I want you guys to do the same thing. Draw a line through this just like I did. So what we have on the left side is a 3x, and what we have on the right side is a 6. Well, my variable is located right here. Okay, and with it on that side is the 3. We have to get rid of what's closest to the variable. So since it's a 3 and they're being multiplied, I have to divide by 3. Notice that they already wrote your division line here. So I'm going to divide by 3, divide by 3. These 3's cancel out. That's how we got our x drop down here. 6 divided by 3 gives you 2. Now what they did here under the check is this. So your original problem looked like this. It looked like 3x equals 6. So what they did is they substituted the 2, which is where we got what we got for a value of x, in where the x was. 3 times 2 equals 6. Does that really work? Absolutely, because 3 times 2 is 6. Notice our two sides work, and you're done. So the sentence is equivalent or equal. Let's go ahead and look at our next example. Actually, it's time for you guys to try a few of these. Okay, so go ahead and look at examples A, B, and C. So I'm just going to prompt you a little bit here. What I want you to do is go ahead and split up your sides, and you're going to do this with all three problems. So you want to locate your variable and isolate it. So that means get rid of whatever's on the same side as the variable. So you're going to be dividing by that number from each side. You will get a whole number as an answer for each of these examples. So go ahead and pause your video now, and when you come back, you're going to see the problems worked out. So looking here, look at letter A. You have 3x equals 15. My x is over here with the 3. So what I need to do to get rid of the 3 is I need to divide by 3 and divide by 3. Notice I wrote it on both sides. My 3's over on the left are going to get canceled out. So therefore x is by itself. 15 divided by 3 gives us 5. So the answer to A is x equals 5. Look at part B. Locate your variable. I see it. It's right there. So with it is a 4. So I have to get rid of that 4. So I'm going to divide by 4 and divide by 4. So I'm going to cancel those 4's out. X I'm dropping down by itself. Even though x is on the right side of the equation, it doesn't make a difference. It's just standing on the other side of the line. That's all that's going on there. So on the left side, we see 8 divided by 4. We get 2. So our answer for B is 2 equals x. And looking at example C, we have a 2x equals 14. Remember, this means 2 times some number equals 14. So I'm going to simply divide both sides by 2. Keep in mind how I'm showing the divide by. So my 2's are going to cancel out, and I drop down my x equals, and then 14 divided by 2 gives me 7. All right, so looking at our next page, so we're all looking at page 553, you'll see where it says division property of equality. What this means is as long as you divide each side of the equation by a number that is not 0, the two sides will still remain equal. And they gave you two examples here. In the first one, they gave you 18 equals 18. If you divide both sides by 6, you're going to get 3 equals 3. You notice that it's the same number on each side. Well, the same thing happens when we're doing algebra. When you have 3x equals 12, as long as what you do to one side is the same exact thing that you do to the other, your equation will remain equal on both sides. When you solve an equation by dividing both sides of the equation by the same number, you are using the division property of equality. So let's look at example 3. Here it reads, Vincent and some friends shared the cost of a package of blank CDs. The package costs $24 and each person contributed $6. How many people shared the cost of the CDs? So this word problem is telling you that Vincent and a few of his friends, and we don't know how many, purchased some blank CDs. So they shared the cost, which means they split up the amount that it cost. So they split it up evenly. So it tells you that what the CDs cost was $24 total dollars, and each person put in $6. How many people shared the cost of the CD? By completing this algebra problem, we'll be able to figure out how many friends Vincent shared the cost of the CDs with. Now, in the example that they have here for you, they drew a bar diagram. The total amount was $24, which is why the bar is at its widest part there. And you'll see the $6 here, which is where I'm breaking it up, or where I'm circling it. And you can see that portion of it is $6, but we need to figure out how many $6 portions we need. Now, if you remember way back when we did this back in a previous chapter, if you keep chunking it by $6, you're going to end up knowing what you need. So we have our $6 here. We're going to multiply it by some number, and that's what's going to give us our equals 24. So what I want you guys to do here is over in the work zone, I would like for you to write 6x equals 24. Just like before, we're going to go ahead and split up our two sides. And now we're going to isolate our variable. Locate the variable so it's on the left side here with the 6. So therefore, since 6 is hanging out with the x, we're going to get rid of the 6. Divide both sides by 6. You get x equals, and then 24 divided by 6 is 4. What the 4 means is that there were 4 people who split the cost of the CDs. That means it was Vincent, he was one person, plus 3 more of his friends. Now I want you to try doing example D on your own. I'll go ahead and read it for you, and when I'm done, I want you to pause the video and try to work this guy out on your own over in the space that they've given you. It reads, in 2004, Penn Hadow and Simon Murray walked 680 miles to the South Pole. The trip took 58 days. Suppose they traveled the same distance each day. Write and solve a multiplication equation to find about how many miles they traveled each day. Okay, so you guys, they gave you a total number here. They told you how long their trip took, and you need to figure out how many miles they walked each day. So think about those numbers and how you're going to put them inside a multiplication equation. All right, so here's what we know. It told us right at the beginning that we have 680 miles that the two people traveled. We know that it happened in 58 days. I'm going to go ahead and use the variable d to represent the distance they traveled. You guys could have used w for walk, x. It doesn't really matter what variable you use as long as it's a lowercase variable. And then I went ahead and put a multiplication dot here because this problem has to be a multiplication equation because it tells you that right here where I've circled it. All right, so if you I would like for you guys to pause the video and copy down this information that I have here, but now we're going to go ahead and put it in an equation. So we know that for 58 days, these two people walked a d distance every 58 days. So every day of 58 days, they walked d miles per day. At the end, it totaled 680 miles. So this is what your equation should look like. 58d equals 680. So you also had to go solve it. So we're going to go ahead and separate our two sides. And to isolate the variable d from 58, we're going to get rid of the 58 by dividing both sides by 58. These guys cancel out here, and I get a final answer of d equals, now unless if you can do 680 divided by 58, I better see your work somewhere. So I'm going to do that off to the side right over here. So if we have 680 divided by 58, I know 58 goes into 68, so 58 goes into 68 just one time. 1 times 58 gives me 58. When I subtract, I get a 1, 0 here, 10, and I'm going to bring down my other 0. 58 goes into 100 only one time. 1 times 58 gives me 58. I'm going to subtract. When I work this guy out, I'm going to get 42. So you'll notice here I'm still left with the leftover amount of 42. So I'm going to go ahead and add a decimal here and a 0, and I'm going to bring down that other 0. So now I'm going to start all over again. 58 goes into 420 7 times. Now don't forget to add your decimal over here up in your answer line. So I'm going to put 7 over here. 7 times 58 gives us, let's see what we get, 3540 here. Subtract, I get a leftover 14. Now, I can go ahead and keep adding zeros here, but I'm going to stop here because in our word problem, there was a key word right over here that said about, which tells us that we could actually, once we get to a certain point, go ahead and just round our answer. So I'm going to go ahead and look at what we have here. We have 11.7 miles, so we can leave it at 11.7 miles. That is the distance that the two men traveled each day to get to the South Pole. Let's go ahead and go to our next example. So now we're on the next page. Look at example 4. It says solve 3.28x equals 19.68 and check your solution. All right, so you can see that how this is worked out here, but I am going to show you the division steps that I want you guys to show me as well. Now, the thing is, though, with this problem is it gives us a decimal divided by a decimal. No big deal. We've done this before, so please don't get scared away and that you don't know what to do with this just because you've got a decimal with these numbers. So over here in our work zone, let's go ahead and copy this down. 3.28x equals 19.68. So just like before, separate your two sides. Locate your variable. It's right here. But with it is a 3.28. So we're going to divide both sides by 3.28. Now over on the left side where your variable's at, these guys cancel themselves out. So now I get left with x equals something. Well, this right here that I'm circling, we have to figure this out. This reads as 19.68 divided by 3.28. I know these are some big numbers. I'm going to go ahead and finish working this out over to the right side of this problem because we have much more room over here. So what I want you guys to do is go ahead and copy down what I've got down here because you're going to need to know how to do this. And this is just a refresher course because we've already had decimals divided by decimals. So our dividend is 19 and 6/800, so it's 19.68. And our divisor, which is on the outside of the box, is our 3.28. So now what I have to do is I can't divide by a decimal. So I need to move my decimal over to the end of the number. Move this guy over 2 spots to the right, but what you do to one number, you have to do to the other. So I'm going to move the other guy over 2 spots to the right. And now I'm going to recopy my problem. So my divisor is 328, and my dividend, which is my number under the box, is 1,968. So now we're going to go ahead and work on dividing this guy out. So we're going to figure out how many times 300 goes into about, I like to think of it as this. I take the front end of numbers. So I think of 3 and I think of 19. And I ask myself, well, how many times does 3 fit into 19? It gives us a good starting point. And I come up with 6. So if you put a 6 right here and multiply it out, 6 times 8 gives us 48. 6 times 2 is 12 plus 4 more is 16. 6 times 3 is 18 plus 1 more is 19. And voila, look what we get. We get a number with no decimal. So therefore, what this means is, let's go back over to the left, x ends up equaling 6. So you guys, on these problems, you're going to have to show me your work. So your steps of your algebra is what you see right over here that I'm putting a box around. However, you do have to still show me the actual division work, and I'm putting a box around that now. So it is required that you do both steps. Okay, so now we're going to put this to the test. I want you guys to work on examples E, F, and G. Now these 3 examples are decimals divided by decimals. We have already had this back in Chapter 2. If you get confused about what to do and how to move the decimals, go ahead and rewind the video and see what I just did with that previous example. We don't have room to do this in your book at all anywhere on this page. So I need for you to get out a sheet of lined notebook paper. So go ahead and pause the video and get that out now. And then go ahead and give these 3 problems a try. When you replay your video, we're going to go ahead and work these guys out together. All right, so here's example E. We have 2.25 times n equals 6.75. So we're going to go ahead and separate our 2 sides. And now what we need to do is locate our variable. So our variable is over with the left side that says 2.25. Well, I have to get rid of that number that's attached to that variable. So I'm going to do that by showing you that I'm dividing both sides by 2 and 25/100ths, and I'm going to do the same thing to the other side. So now on the left side, those 2's get canceled out. So I'm going to drop down my n and my equal sign. But what I have to do now is I have to go ahead and take care of this division work right here that I just put a box around. So we're going to do that to the right of this problem. So what I'm going to do is I'm going to go ahead and write out 6.75, divided by 2.25. Now we can't divide by decimal, so I'm going to take the decimal in my divisor spot and move it 2 spots to the right. And I'm moving it 2 spots just so I can get far enough over to make it a whole number. So now I'm going to do the same thing with my dividend. So what we have to do next is, of course, recopy our problem. So I'm going to go ahead and just do it actually right next to it again. So I've got 675 divided by 225. So what I'm going to do is, I said this before, I'm going to look at only my front numbers. So look at the 2 and look at the 6. And I'm going to ask myself, how many times does 2 fit into 6? Well, hopefully you guys said 3. And it gives me a good starting point. 3 times 5 gives me 15, so I'm carrying my 1. 3 times 2 gives me 6, plus 1 more is 7. And 3 times 2 gives me 6, and voila, look what we get. We get 3 as our final answer. Now don't forget to bring it over and put the final answer in our actual equation problem. All right, let's look at example F. So on this one here, you have 1 7/10 B equals 8 5/10. This one's a little bit friendlier looking because the numbers aren't as big, but you can see that as I'm going through here, my steps are always going to be the same. No matter what the numbers look like or how hard they are, I'm still going to go ahead and just do the same process. So you notice that what I did is I divided both sides by 1 7/10, and they're always going to get canceled out on the side where the B is. So what I'm left with having to do now is having to do my 8 5/10 divided by 1 7/10. So of course I'm going to do that over to the right side. I'm going to go ahead and copy it down here. So underneath my box, I've got 8 5/10 divided by 1 7/10. Just like before, I can't divide by a decimal, so I've got to move both of these guys over. Now the reason why I moved the decimal over one spot is because I only needed to move it one spot to get to the end of the number. So I'm going to go ahead and recopy my problem. So now on this one here we have 17. I don't want to sit there and say, well, how many times does 1 go into 8? Because then you come up with an 8, and that's not going to give us the best estimate. But what you're going to do is think about 17 and how it's close to a 20. So that I think, to myself, about how many times does 2 go into 80, and you get about 4. Now I'm going to do the 17 times 4 off to the side just to see what I get. I get 68. But looking at this, if I were to plug in 4 over here, I'm a little too low, and I believe 5 is going to be a better number. But let's test this guy out. 5 times 7 gives me 35. 5 times 1 is 5, plus 3 more gives us 8. And look what we get, an even 5. Well, 5 is not an even number, but a solid, no decimal type answer. So back to my answer line, I put in B equals 5. So our last example, G, reads 61 5/10 Y equals 55 35 hundredths. So what we have here is, please remember that what's happening between the 61 5/10 and Y is multiplication. So just like I have in the previous examples, I'm going to go ahead and locate my variable and find that whatever's with the variable, I want to divide it out, get it out of the way. So you can see here what I did. I divided both sides by 61 5/10. Now, my guys over here on the left are going to get canceled out, so I bring down my Y equals. But over here, I need to go ahead and take care of my 55 5/10. Oops. I need to take care of my 55 5/10, or 35 hundredths, divided by 61 5/10. So off to the side, that's where we're going to do our work. So we're going to go ahead and write, under our box, 55 35 hundredths. Remember, this is our dividend, and we're dividing it by the divisor. So outside of the box, we're going to write 61 5/10. Now, just like before, we have to move these decimals over. So we're going to take our decimal and our divisor and move it to the very end of the number. We only needed to move it one spot, which means that my dividend number gets his decimal moved only one spot. We'll look and see where it's at now. Now it gets relocated to this spot right here. And make sure that you remember to slide it up. But let's go ahead and recopy this problem so it's a lot neater. So we have on the outside a 615, and on the inside we have 553 decimal point 5. Now before I get started, I'm going to take that decimal point and slide it all the way to the top. So this way I don't forget about it when I'm doing my division work. Alright guys, I had a huge brain fart moment, so look what I did here, and hopefully you guys picked up on it. What I did was, I wrote 61.5 when it really should be 6.15. I was looking at my problem thinking, something doesn't look right. So we're going to scratch that, and hopefully you guys have it correct on your paper. So I'm going to rewrite my problem here, 6.15, y equals 55 35 hundredths. Alright, so going back, I'm going to go ahead and still divide my two sides by 6 15 hundredths. So now when I go over to my right side to move my decimals over, I still have my 55 35 hundredths under my box. On the outside though, I have 6.15, and because I have to move my decimal over 2 spots to the right, 1, 2, this guy's decimal gets moved over 2 spots to the right. So what we end up with is 615 on the outside and on the inside a 5535. So no decimals at all. Okay, so I know these are really big numbers. So here's what I want you guys to think about. So I look at my 615, and I know that it doesn't fit into 5, which is the first number I'm looking at. I know it doesn't fit into 55. I know it doesn't fit into 553. But obviously it's going to fit into our 5,535. Now, if I were to take 615 and let's say I multiplied it by 10, which means all I'm doing is adding a 0 to it, that's too big. So, because the number is so close to the 6,150, so therefore I'm going to go ahead and give 9 a try to see if 9 works out. So I get 9. 9 times 5 gives us 45. 9 times 1 is 9 plus 3 more gives us 13. I'm carrying my 1 there. 9 times 6 is 54 plus 1 more is 55. All right, that works out so much better. So now let's go back over to our equation. So this is where we get y equals 9. And that is our final answer. All right, so now we're at the end. This is your assignment. You're going to complete the guided practice. I want you to do questions 1 through 5, and you need to show your algebraic steps. That means I want to see that you're dividing the equation by between two sides with the line going down the middle. I want to see your divide by symbol, which is a fraction bar. And when you get to questions 4 and 5, although they give you a word problem with only one line, you still must show algebraic steps. So for question number 4, you can go ahead and put your algebra right over here in the box that I drew. And for question number 5, you actually do have enough room right over here to show that algebraic step in that box there. All right, you guys, we will see you back at school tomorrow. All right, well, have a good one. All right, that's better. I made my corrections here with my question mark and my SpongeBob spelled correctly. All right, guys, we'll see you back in class. Have a good one.